Alright, this is a presentation by group B25 on permutations and combinations. Our group consists of Anurup Arora, Zachary Berg, Rachel Chow, Dominic Corona, and Omid Gomeshi. And this video is hosted by noatom.com. If you want to learn more discrete mathematics, please visit noatom.com for more videos. Now, where exactly are permutations and combinations useful, and what can we apply them to? Well, consider the question, how many ways can we select 3 students from a group of 5 to stand in a line for a picture, or how many different committees of 3 students can be formed from a group of 4? This is exactly where we need permutations and combinations, and you should be able to answer these questions by the end of the video. So, what exactly is a permutation? Well, a permutation of a set of distinct objects is an ordered arrangement of these objects, and this ordering is important. So consider the set S, where S equals A, B, and C, those 3 elements. C, B, and A is a permutation of S, and B, C, A is a different permutation of S. This is where the ordering plays in, and what makes a permutation different from a combination. All 3 of these are considered different permutations. So an R permutation is an ordered arrangement of R elements of the set. It's just basically a way to count the number of arrangements you can form out of R elements. So consider the ace of spades, 5 of hearts, 7 of clubs, 10 of spades, and 3 of spades. This is a 5 permutation of the set of 52 cards, or one way you can arrange 5 of the 52 playing cards. So the notation we use for this is P parentheses comma N comma R. The poker hand, like we said above, is 1 of P of 52, comma 5. So N in this case stands for the number of elements in the set, the total number. So for the cards, it's 52, obviously. And R is the number of things you want to arrange. In this case, it's 5. That's the number of cards in a poker hand. So how do you calculate a general permutation? Well, let's think about this, and let's use the poker card example, or poker card situation as an example. When you first start, if you're choosing 5 cards, you have 52 choices. So that's 52 different ways you can choose the first card. So after you choose that, you have 51 cards left, and you need to choose 4 more cards. So for the next card, you have 51 choices. Well, we know by the general product rule of probability theory that for the first 2 cards, you just multiply them. So it would be 52 times 51 ways for those first 2 cards. And you proceed until you get down to the last one where you have 48 choices. And you multiply all those together. So 52 times 51 times 50 times 49 times 48. And that gives you the total number of permutations that you can have of 5 cards out of 52. So general formulas for this is n times n minus 1 times n minus 2 all the way to n minus r plus 1. Now a simpler way to write this using factorials is n factorial over n minus r factorial. This gives you exactly the same thing, n through n, or n times n minus 1 all the way to n minus r plus 1. It's just a neater way of writing it. So let's move on to some examples of permutations.
For our first example, we will try and figure out the number of 5-digit numbers. Because we know that there are 10 digits to choose from, 0 through 9, and 5-digit places to put them in, we know that there are 10 times 10 times 10 times 10 times 10 5-digit numbers. This equals 10 to the 5th, or 100,000. This number includes numbers that have repeated digits. So we call this permutation with repetition. For this next example, we want to find how many different 5-digit numbers there are that do not repeat any digits. Again, we have 10 different digits and 5 places to put them in. But in this case, it's 10 times 9 times 8 times 7 times 6. Because each time you choose a digit, there's 1 less digit to choose from for the next digit. This equals 10p5, or 30,240. We call this permutation without repetition.
Alright, Now let's move on to combinations. What exactly is a combination and how does it differ from a permutation? Well, in math, a combination is an arrangement in which order does not matter, and this is important. This is the main factor that creates a difference between permutations and combinations. And it defines how many ways you can choose a group from a larger group. So, like our second question was in our examples, how many ways can you choose 3 people out of 4? So, like I stated earlier, a combination of an R combination of elements of a set is an unordered selection of R elements from the set. The notation for this is similar to permutations. It's C parentheses n comma R. But in this case, to use our example from earlier, actually to use this example, if we have a set of 1, 3, and 4, that's a 3 combination of S, where S is a set 1, 2, 3, and 4. But 4, 1, and 3 is the exact same combination. You only count that once, whereas in a permutation, those would be different. This is the main difference, and if you think about that, that means that a permutation must have more arrangements than a combination. Or, in other words, you're overestimating. And that reflects in the formula for a combination. A combination is n over n minus r factorial, but you also have to divide by this new factor, r factorial, to account for the fact that you overestimate when you do a permutation. So you don't need all those extra arrangements like 4, 1, 3, because they're the same thing as 1, 3, 4. And an important point on this is that a combination, you can say C and R, it's the exact same thing as choosing C of n and n minus r. So 9 choose 5 is the exact same thing as 9 choose 4. And it's pretty easy to prove using the formula for combination. And let's see some examples of those in action.
In this next example, we'd like to make a meal out of 5 different food options we have to eat: apples, bananas, cake, donuts, and eggs. We would like to choose 3 of these items to make our meal. How many different ways can this be done if you can only have a maximum of 1 of each item? We use our combination equation, n factorial over r factorial times n minus r factorial, to get this answer. We plug in our numbers, 5 factorial over 3 factorial times 2 factorial, to get 10, which is the amount of combinations of ways that we can make our meal. For this example, we're again trying to make a meal out of 5 different food options we have to eat. We would like to choose 3 of these items to make our meal. The difference, though, is that we want to find how many different ways this can be done, assuming you can take as many of each item as you want. We use the combination with repetition equation, n plus r minus 1 factorial over r factorial times the quantity of n minus r factorial. We plug our numbers in, 5 plus 3 minus 1 factorial over 3 factorial times 5 minus 3 factorial. This equals 35, which is the number of different combinations we can use, assuming that we can take as many of each item as we want.